Assalamualaikum and good day to Dr. Fakurazi Idris. We are from Group 6 and we will present binary phase shift keying Bpsk. Okay, first of all, my name is Farah Nushohana binti Zainuddin and I will start with the introduction. For the introduction part, the basic theory behind digital communication is that digital data and information are transmitted from one place to another across an analog channel. To be more particular, passband digital communication requires the modulation of an analog carrier signal's amplitude, phase, or frequency with a baseband signal. And then the simplest type of digital phase modulation is binary phase shift keying or Bpsk. The digital phase modulation signal is a series of 1 and 0, thus the term of binary. In this digital phase modulation, the carrier signal is directly phase modulated. A single bit is represented by each symbol in the Bpsk signal. The carrier phase is adjusted when binary data is used as input. And then the carrier signal is applied to a balance modulator from the Bpsk signal. And then for the theory part, as previously stated in the introduction, the binary phase shift keying Bpsk method modulates the phase of the carrier signal using binary symbol, which is 1 and 0. The carrier is assumed to be St equal to A cos 2 pi Fc t, with A becoming the sinusoidal carrier's peak value. In Bpsk generation, a signal is produced by passing a carrier signal to a balance modulator. The balance modulator receives the baseband signal, which is Bt, as a modulation signal. Otherwise, the balance modulator serves as a phase reversing switch in a Bpsk transmitter. There are two ways to get the carrier signal to the output. When transmitted to the output, it can be in phase or 180 degrees out of phase with the reference carrier oscillator. The carrier signal and binary digital data are both input to the balance modulator. In order for the balance modulator to work in the Bpsk transmitter, the digital input voltage must be larger than the peak carrier voltage. And then when receiving a Bpsk signal, it has this formula form, and during the modulation, the original Bt signal is written. That's all from me, and I will pass the next to Aimee Fazana.
Assalamualaikum to Dr. Fakrul. My name is Nurul Aimee Fazana binti Muhammad Zaidi. Today, I will show the Bpsk modulation and demodulation in MATLAB code. First, at digital binary input information, we set the input equal to X to enter the digital input for 0 or 1. Next, this is the code that represents the information as digital signal. For Bpsk modulation, we set the carrier frequency equal to 10, bit rate equal to 1 over time bit, and for the carrier frequency, bit rate multiplied with 10. Okay, this is the carrier phase for binary input 1, this is the carrier phase for binary input at 0. Okay, for transmit signal, we set X equal to mode and channel mode for H and W. We set H equal to 1, where the H is signal fading and W equal to 0, which is the noise. At receive signal, Y equal to H multiplied with X plus W is the convolution. For Bpsk demodulation, to calculate the carrier, C is equal to cos multiplied with 2 pi Fc multiplied with T4. This is the convolution, integration and logical condition. This is the coding that represents the demodulated information as digital signal. Okay, now we will run to enter the digital input. Okay, now this is the Bpsk modulation and demodulation output waveform. First, a digital input signal. This is the input where we put 0, 1, 1, 0, 1, 0, 1, 0, and this is the Bpsk modulated signal. Next, this is the Bpsk demodulated signal. When the digital signal from 0 to 1, the Bpsk modulated signal show the sine waveform convert from 0 to 180 phase. For the demodulated signal, it shows the same waveform with the digital input signal. Okay, next for the Bpsk modulation and demodulation in Simulink MATLAB. Okay, at the binary info, we put the signal that same as MATLAB code. At carrier signal, we set the frequency to multiply with pi, and the phase is a 90 degree. Then this is the product and scope to display the output waveform. Next, we need to run. Okay, this is the output waveform from the scope. At the binary info, input signal is 0, 1, 1, 0, 1, 0, 1, 0, same as the MATLAB code. At binary info, when the signal is at low input, the Bpsk modulated will turn into 0 degree. But when the digital signal at high input, the waveform of this sine wave will become 180 degree. It shows the same when the binary convert from 0 to 1. At the Bpsk modulated, the sine wave will convert from 0 to 180 degree phase. That's all. Thank you.
Hi, my name is Nosara Ali Shabik Muhammad Jazalan. My metric number is P022010122. Now it's my turn. I will explain about the conclusion. So, binary phase shift keying (BPSK) is a digital modulation system that transmits data by the modulating two split phase of the reference signal, the carrier wave. The constellation points are commonly arranged in a circle with regular angular spacing. This results in the greatest phase difference between nearby locations and, as a result, the strongest protection against corruption. They are arranged in a circle so that all of them may be communicated with same energy. And also, for this assignment, the model-based design and analysis of the binary phase shift keying digital modulation technique for the noiseless and noisy transmission have been accomplished in this assignment.